What's good, guys? Welcome back to my channel. In this video, I'm going to be showing you how to solve this problem on LeetCode word search. This is the second video in my LeetCode series, and before I get into the code, I just want to thank you guys so much for 50 subscribers. That's a huge milestone, and I appreciate all the feedback that you guys have been giving me, and let's aim for 100 subscribers. Alright, now let's get into the video. Basically, in this problem, we're given a board and we have to determine if a certain word exists in this word search. So, for example, in this word search, we have to determine if the word A, B, C, C, E, D exists. And so the way to construct a word is basically a word can be constructed from letters of sequentially adjacent cells. So what that means is that if we have A, then we can look on its right, we have B, and on B's right, we have a C, and below C, we have another C. So basically, we can form words using, like combining the words, the cells right next to them, right? Up, down, right, or left, but not diagonally. So here's another example, the word C, so we can form that by S, E, and E. So we have to return true or false based on whether or not the word exists. So now let's get into the code. We're just going to do this on Visual Studio Code because that's what we're used to. And so what we're going to do is we're going to define a word search function, and we're going to take in two arguments, board and word. Now the board is the word search itself, and the word is what we're trying to determine if that's in the board. So the approach that we're going to take here is backtracking, and if you don't know what backtracking is, you can check out my Sudoku solver video. That's a great video as well, and it will give you a good introduction on backtracking. I'll link it in the description if you want to watch it. Now, what we're going to do here is we're going to make a solve function that basically finds out if that word is in the word search, and to do that, we're going to have a main for loop here that's going to be running the main thing. And so for row in board, and then for square and row, we're gonna run the solve function on the first letter of the word. So for example, if we have the word acorn, and we're gonna look for the first letter first. That's gonna be A. So that's the 0th index first letter, and we're gonna have to go through the entire board, and the first A that we find, we're gonna run the solve function on it. Now, the solve function, it uses backtracking, which uses recursion. Recursion is where you call a function when the function is being defined. And to stop an infinite recursion loop, we're going to have a condition at the top so that when the word is done, when we found the whole word, then we stop. Okay, now this is just to keep us from going out of bounds. We have to make sure that the row column coordinate is inside the board. And also the problem back here, it says that the same letter cell may not be used more than once. So for example, if we have the word ABCB, so we can't just form it with like A and then B and then C. But here's the thing, you can't go back and use B again because you can only use a cell one time. So to prevent that from happening, we're gonna have a list called visited, where basically we're going to store all the row column coordinates, and if we find that coordinate again, and if that coordinate isn't visited, that means we've already been on that cell, then we're not going to go on it. And also we've got to make sure, again, just in case, that the board, that certain coordinate, it is the letter that we're trying to find. Okay, so if any of these are just like conveniences, we have to make sure that these cases are taken care of. Now the main part of the function is basically here. So first we're gonna append, if all goes well, then we're gonna append the row column coordinate to visited, and then what we're gonna do is we're gonna check all of its neighbors. So for example, if we're on A, we're gonna check all of A's neighbors. We have to find a C in order to get through acorn, ACORN. So we're gonna look at the square right above it, then the square to its right, then the square below it, and then the square to its left. So in all of these four cases, we're gonna run the solve function, and wherever it returns true, we're gonna go into there. So basically, let's say the letter C is gonna be right above the letter A. So now when we call the solve function, we go back to the top when this function is being defined, and again we take care of all of this, and then now we're gonna run it again. Now this time we're on C, right? So now the letter value, this is actually 1, not 0 anymore, because we're not looking for the 0th index, we're looking for the first index, or the second letter. So that's why the solve function takes in that letter argument. Now again, we're gonna pass in the letter plus 1. Now we're trying to look for letter O. So we're gonna look at all C's neighbors, and then we're gonna run all these functions, and now we're gonna this is gonna create a bunch of paths, and whatever path works, right? That if it does work, then we're gonna return true, because here's the thing: if we go through A, C, O, R, and N, and then we reach this condition at the top. So if letter equals to the length of the word. So if the letter is 5, like acorn, it's 5 letters long, and if the letter that we're on, its value is 5, and then the length of the word, that's also 5, then we're going to return true, because that means that we found the entire word. We're on the last letter, and now we can return true, and we can be rest assured that that word is indeed in the word search. But if anything goes wrong in the process, let's say, for example, we find a dead end. If we go through A, C, O, but in O's neighbors we can't find an R, then we're going to have to take a step back and then try another path. So that's called backtracking. And if we find a dead end everywhere, if that word isn't even in the word search, then we're going to return false. So that's how it works. Now let's test this. We're going to use the same example from the LeetCode problem, and let's run it. So it returns true because the A, B, C, C, E, D, this is indeed in the word search. Now let's try the other example, C, and now let's run it. And again, we have true again. So that was word search in LeetCode. I hope you liked the problem and my solution to it. And if you did, don't forget to hit that like button, subscribe button, and share the video with all of your friends. That was it for this one, and I'll see you in the next video.